Unit 2. We are doing part 2 of 2.1, and we're going to start with adding and subtracting like terms. Right, so we can only add and subtract like terms, and an important thing is whatever that variable part is which makes it a like term, it doesn't change when you add or subtract. In other words, 3x plus 2x, think of it simply as I have 3 x's and then I have 2 more x's. Now altogether I have 5, but they are still x's. They don't change. Right, let's look at an expression where we're going to add and subtract like terms. So we have 10x to the 3 minus 4x squared plus 5x to the 3 plus x minus a half x plus 6x squared. So we're going to look for the like terms. The 10x squared, we know there's an invisible plus in front of it. X to the 3, not squared, plus the 5x to the 3. They are like terms, so we will say 10 plus 5 is 15, and they will remain x to the 3's. Also notice that I'm doing them from the highest power, so now the next power is squared, so I'm going to look and notice that I include the sign in front of it. Negative 4x squared plus 6x squared. So if I have 6 rand and I spend 4 rand, then I still have 2 rand left. Or if I had 6x squared and I dropped 4 of them, then I still have 2x squareds left. Then my x terms are all together here. So I have, again, here's an invisible 1. I've got plus 1x, take away a half x, which leaves me with plus a half x. So please remember to keep the correct signs to the left of each term, even if you need to swap them around. Okay, let us have a look at this. What if I asked you to calculate x minus y? Is there anything we can do? No, they are not like terms. So your answer just remains exactly what it is, because x's and y's are different. You can swap them around and put the y first, but remember the negative must go before it. To the left of the x we had an invisible plus, which now we have to write. So x minus y you can write as minus y plus x, but that's all you can do because they are not like terms. Right, so you add the like terms, you don't change the name of the term. And if they're not like, if they're not the same, exactly the same variable part, then you can't add them. Let's have a look at exponents. Exponents are similar words, are powers or indices. So if you had to read up on exponents and the book has a chapter on powers or indices, it should be similar work. Right, what do we mean by that? If I have anything to the power of 4, then it means times it by itself 4 times. So if I have 4a, that is not an exponent, that means add it to itself 4 times. So let's look at an example for each. If I had 2 to the 4, then I meant 2 times 2 times 2 times 2, which gives me 16. If I had 4 and now I need my bracket because it's not variables, I can't just write 42, then I'm saying 42. Then I mean 2 plus 2 plus 2 4 times, but we also just know 4 times 2 is 8. So note the difference. 4a is not a power, it's simply adding 4 of them. Some important rules regarding indices. One is that any number to the power of 1 is just itself. So basically, if you see any variable with no power, then there's an invisible power of 1. So if I just had an x, it actually means x to the power of 1. The other rule is anything, let's just use a different variable, to the power of 0 is 1. Anything to the power of 0 is 1. There's one exception. Not 0 to the 0. That again is undefined. Not allowed. Against the rules. Okay, so I could have something like this. If the power is 0, then the answer is simply 1. Simply 1. I don't need to worry about everything in there because the power is 0. Be careful though, if I gave you this, then the answer is -1. But if I gave you this, the answer is +1. Always your brackets are extremely important. The first example says, first find 3 to the 0, which is 1, then put a negative in front. The second example says, take the whole of -3, put it to the 0, so the answer is simply 1.